Yes, we are all set.
Thank you, ma'am, for giving such a lovely introduction about me and inviting me here as a speaker for this webinar. My sincere thanks to all the participants who are actively listening to me. I want to share some of my experiences that I have gained all these years on energy audits, particularly when HVAC system retrofits were on the target. Everything cannot be covered in the whole gambit of things, but a little flavor of what energy audit means in context to the HVAC systems and how it plays an essential role in HVAC system retrofits would be my endeavor. Before moving forward, I request the host to mute everybody's audio and disable the video feature for a better connectivity. All of you are requested to please put your mobiles in silent mode for next couple of minutes and keep yourself isolated in some corner of your place. At the end of the session, 10 minutes slot is also reserved for Q&A. Way back to our academic days, we all have studied the first law of thermodynamics, right? Which states that energy can neither be created nor destroyed, but can be transformed from one form to another form. During this energy transformation, some amount of energy wastages also occur through the medium. Say, for example, an electric bulb or a tube light. When electricity is allowed to pass through them, electrical energy is converted into light energy, right? And some amount of energy is transformed into heat energy. That goes wasted because we cannot tap that heat energy. In this case, how much electrical energy would be converted into light energy and how much energy would be wasted in the form of heat energy? It all depends on the efficiency of the bulb or the tube light, right? The same principle applies in HVAC systems as well. In the next couple of minutes, we will be discussing on how to identify the energy wastages in an HVAC system and how to tap the energy that otherwise goes wasted. Mostly it is noticed that the budding engineers fail to explore the key areas of energy savings in a building and end up with tapping small amount of energy savings that demotivates the building owners. It is obvious that with the deliverance of such insignificant energy savings, the expectation of the building owners or the facility managers or the end users gets defeated and they lose trust on energy management. So keeping that in mind, means such a disappointing scenario, this presentation is crafted, emphasizing on certain agendas. So you all may be seeing a list of agendas that are outlined on your screen. Let's have a quick glance on those agendas. The first one on the list is the background, followed by HVAC system optimization, need for HVAC system optimization. How is HVAC system optimization done? Energy audits, types of energy audits that include walkthrough audits and detailed audits, energy audit requisites, areas of focus during the energy audit, interactive effects, principles of energy audit, energy conservation measures, HVAC retrofits, and return on investment. And at the end, we will discuss a case study, and to support my claim on energy audits and the case studies, I will present testimonials as well. Almost all the end users believe a notion that the air conditioning is simply a cooling system, which is absolutely a myth. Being energy professionals, we all must be aware of the function and the purpose of HVAC system in true sense. Because HVAC system is one of the major sources of energy consumption in almost every building. And we all know that the main function of HVAC system in any building is to create a comfortable environment. If it is obviously, if it is designed for comfort application, a comfortable environment can be created by maintaining the right temperature, controlling the RH, regulating the airflow, governing the cleanliness, and leveling the noise. As an energy professional, we all need to know that HVAC system is an energy guzzler in almost every building. And almost 60 to 65% of the energy consumption is contributed by conventional HVAC system in a building. Most invariably, building sector consumes almost 40% of the available electrical energy. So our role is to focus on the smart solutions to reduce down the energy consumption through optimized HVAC system design and its operation. Now, we all need to understand one thing. What exactly HVAC system optimization is? It is not a simple method. It's a critical method to reduce down the energy consumption. But it comes with certain clauses, like the optimized HVAC design emphasizes principally on reducing the energy consumption without compromising on the indoor environmental conditions. Similarly, optimized HVAC operation focuses on controlling the energy wastages, but a clause added to it that the comfort level of the occupant should not be disrupted. That should be the intent. Now, moving forward, let us see why every end user needs to be energy conscious. And as an energy professional, why we need to motivate the building owners and the end users to be particular on energy savings. One of the major reasons that should trigger every building owner and end user to be firm on energy usage is because of the rising electricity tariff. In the last few decades, electricity tariff has increased exponentially, right? By controlling the energy usage, building owners can save a lot and earn good profits. Since energy, HVAC, sorry, not energy, since the HVAC has become a part of our daily life, obviously energy is also a part of our life. So it is inevitable to explore the various possibilities of the HVAC system optimization. Now the question in point is that how to optimize the HVAC system or how to initiate the process. Straight away, without a second thought, I say that it has to be started by conducting energy audit, followed by analyzing the system flaws and identifying the pain areas. The next step is that all the observations should be reported to the client, combined with the proposal for energy conservation measures as a solution to the hitches for system revival. And let the client take a call on it. Whenever energy audit for HVAC system is in discussion, there is always a debate. Due to the lack of knowledge, end users often interpret energy audit in their ways. Some interpret energy audit as the process of measuring the parameters, while the building owners view it as an irrelevant activity that involves wasting of hard-earned money due to the lack of awareness. My say on it is different. Energy audit is in fact a process of energy efficiency assessment of a particular plant under consideration. It is a broader subject that involves a complete building and system survey involving examination, collection of the historic data, and usage patterns of a system or a plant. It involves the study of the output and the plant behavior as well. Broadly speaking, it can be classified into two categories: walkthrough audit and detailed audit. Sometimes Detailed audit is also called as the deep or thorough audit. Let's have a look on the walkthrough audit. In context to HVAC, a walkthrough audit is like a general physician or a doctor examining a sick patient. You might be wondering, why did I stick this particular picture on this slide? That is just to create an awareness that energy or a walkthrough energy audit is like a general physician or a doctor examining a sick patient. It's as simple as that. All the studies are done at a surface level, involving the collection of various data like the equipment age, examining the operating parameters at various loads and various instants of time, plotting the building energy consumption and the HVAC system energy consumption, etc. Based on the plant room and the system survey, a generalized solution is proposed. Now let's talk about a detailed audit. A detailed audit is like a medical expert having specialization in a particular area, diagnosing the disease of a patient. All the studies are done at a deeper level to gain the complete insight of the disease. Therefore, a detailed audit involves conducting testing and measurements to evaluate the heating and cooling outputs with respect to electrical power inputs. Obviously, the power quality is also checked, and the scope for power factor improvement, that is also checked, followed by performance assessment. Whenever conducting energy audit on HVAC systems is in talks, one should not forget that there are certain prerequisites for it, like calibrated instruments, qualified staff competent to perform testing at sites, operating data of the equipment for last 1 year, technical data sheet of all the equipments, power quality reports, and last but not the least, a competent energy auditor to analyze the data and interpret the reports. So, conducting an energy audit, I may be harsh in saying right now, so conducting an energy audit is not a roadside vendor's cup of tea. Everybody cannot conduct energy audit because people have a notion in their mind that if so, that energy audit can be conducted by using a clamp meter or a tester or a screwdriver. It's not like that. You have to spend money on it to retain money out of it. Failing to arrange any one of the of anyone from the list may lead to biased and manipulated reports which don't have any relevance or sanctity. After all, whatever that is reported, based on it, the call should be taken by the client. While performing energy audits on existing old HVAC systems, following areas should be focused: equipment rated capacity versus actual capacity under certain set of conditions, equipment installation location, air distribution system, hydronic piping layout, and refrigerant piping. And there are multiple things on the count. I didn't want to list everything here. Since entire HVAC plant is scattered in tits and bits across the building, therefore it becomes way too difficult to comprehend the entire system without having a proper as-built drawing in hand. Because of the implementation of the proposed ECM or the energy conservation measure, that may be good for the system within the boundary, but may not be ideal for the system out of the boundary. And due to the interactive effects, mostly HVAC systems give troubles with the implementation of new ECMs. And that's the reason why it's recommended that an energy auditor must verify the as-built drawing before producing the report, and to study the system within the boundary and out of the boundary. Energy audit is a complex activity that principally depends on the accuracy of testing and measuring instruments. If there is a lack of testing or unavailability of testing and measuring instruments at site, then the accuracy of the reports will be in question. The accuracy of the observations, the accuracy of the findings will always be in question. The reliability of the data shared by the end user, sometimes or most of the times, the reliability of the data shared by the end users, that's always in question. So a transparency should be maintained between the auditor and the end user. Auditor should be transparent enough with the end user, and the end user should also be transparent with the auditor in sharing the data that is available with them. Last but not the least, the capability of the energy auditor. that should also be factored, because whoever produces the report, the energy auditor, should be competent enough. It's not that only a certified energy auditor can do everything. It's all about the capability, the intellectuality, and the experience the energy auditor is having. That matters a lot. So sometimes people ask me, what is meant by ECM or energy conservation measures? Energy conservation measures, or you can say it is a way to tap the energy savings. With their implementation, once the energy audit is conducted, various opportunities are explored to tap the energy savings, and that's how the energy conservation measures, they come into picture. And the implementation of any one that is reflecting on your screen, any one of the list or from the list, like the system upgradation with latest technologies, improving the operating practices, monitoring and controlling the loading patterns of the supportive equipments, insulating the subsystems, like air distribution and water distribution systems to restrict the energy wastages, and sticking to maintenance schedules. These are all a part of ECMs only. Now let's understand HVAC retrofit in context to energy savings. Implementation of energy conservation measure in itself is a retrofit job. If you ask me that way, I can put it this way. Implementation of any one of the energy conservation measure in itself is a retrofit. It involves equipment replacement, relocation of the existing setup, modification of air distribution system or water distribution system, or else integration of automated control system. These are all come under HVAC retrofits only. And moreover, these are all ECMs as well. So whenever the proposals are submitted to the client post conducting energy audit, the first question that always raised by the client is, what is ROI, or what is the payback period? The implementation of energy conservation measure attracts some capital that every end user desires to recover, right? The time period that is needed to recover that investment by the implementation of energy conservation measure is the payback period, usually calculated on the basis of several considerations like the number of hours the system operates throughout the year, electricity tariff, and dependency of the user on the upgraded system. Or I have discussed with you a lot on energy audit and ECMs. Now I have brought a case study for you. This is one of the topmost renowned hotels in the vibrant city of Mumbai, located next to Powai Lake, consisting of 700 rooms. Formerly, it was known by the name of Renaissance Hotel. Now, I believe that it is renamed as Westin Hotels. Those who are from Mumbai or those who have visited this hotel might be aware of it. The air conditioning facility to the whole building was served by an HVAC plant that consisted of 2 water-cooled centrifugal chillers of 700 TR capacity each, 4 water-cooled screw chillers of 380 TR capacity each, primary pumps 4 numbers without VFDs, secondary pumps 14 numbers with dead VFDs, those VFDs which were not functional. It's as good as not having VFD. Just for the sake of eye washing, those dead VFDs were coupled to the pumps, which were completely inactive. Condenser pumps 6 numbers and cooling towers 11 numbers. Small cooling towers were installed there. And due to the non-performance of the chiller plant, an energy audit was conducted in the year 2014, and based on the findings, a few ECMs, what we call it as energy conservation measures, were proposed. Proposed ECMs was to replace the existing HVAC plant setup with 2 water-cooled screw chillers of 550 TR capacity each. Out of the 4 existing water-cooled screw chillers 380 TR capacity each, 2 existing water-cooled screw chillers were retained. Primary pumps 4 numbers coupled with VFDs. Existing old secondary pumps were used as it is, 14 numbers, but new VFDs were mounted on those secondary pumps. Condenser pumps 4 numbers with VFDs, and all 11 cooling towers were replaced by 2 numbers of low approach cooling towers. And one more new system was added to the plant room, that is automated tube cleaning system. One single system was serving to both the new chillers of 550 TR capacity each, along with automated logic control system that we call it as chiller plant manager in layman's language. Considering the proposal, the HVAC retrofit project was started in the year 2015 and was successfully completed in the year 2016 with a lot of pains and challenges. No doubt, whenever there is a retrofit project, there will be multiple challenges because the whole building will be in operation, and the entire work has to be performed during the odd hours or non-working hours. That needs a lot of shutdowns, and by the next day, the plant has to be in operation because the occupants in the building won't be ready to compromise their comfort. The commercial value of the retrofit project was 5.85 crores, almost 6 crores, you can say. And post project completion, it took almost 3 months for the system, for the complete HVAC system to tune up, because there were multiple inclusions and exclusions in that complete setup. The energy savings were computed and reported from 2017 onwards. Now, let's see the impact of HVAC retrofit. ESCO has committed to deliver 22,60,000 kWh of energy savings with the implementation of ECM, proposed ECM. But to the surprise, the actual energy savings delivered was much beyond the expectations. Here, I would like to make you clear that 1 kWh equals to 1 unit. So during the discussion, if I say 1 unit, then it should be understood that 1 unit equals to 1 kWh. So in the first year, 46,45,000 units of energy savings was delivered, which is about to double of what was committed. Isn't it mind-blowing? In the second year, 44,85,000 units of energy savings was delivered. $43,25,000 units of energy savings was delivered, which is closer to double of what was committed. On the top of it, with these achieved figures of energy savings, the hotel was conferred with 18th National Award for Excellent Energy Management 2017 by the Confederation of Indian Industry, CII. And the image, the photo, the picture that is visible on your screen itself is a testimonial for it. It's an evidence. Having said that, it is evident through this case study that energy audit, if conducted meticulously and the ECMs are implemented diligently, then the outcomes will be astounding. And this certificate, this National Award certificate conferred by CII itself is an evidence for it. And this is a proudest moment for me to share with you all that the said retrofit project was headed by me, where I got an opportunity to demonstrate my capabilities in delivering the energy savings consistently year after year. The endeavors that I had put in the project was acknowledged by the top management of that hotel and conferred me with an appreciation letter that is displayed on your screen. Anyone of you having questions within the purview of the covered agendas today can put it across. Have any questions from anyone?
Yeah, just hold. I'm reading it out.
But it should be within the purview of the covered agendas.
Yeah. So the question is from Mr. Ranjit Raj, and his question is: what are the major ECMs recommended to the Renaissance Hotel mentioned in the case study?
Can you please come again, ma'am?
Major ECMs recommended to Renaissance Hotel for mentioned in the case study. The case study which you mentioned.
Yeah.
That's asking about the ECMs.
Yeah, that has already been mentioned in the previous slides.
Yes.
The first ECM was replacement of all the existing chillers with 2 water-cooled screw chillers of 550 TR each, right? And out of the 4 water-cooled screw chillers of 380 TR capacity, 2 were retained back as a backup in case if this 550 TR chiller fails during the operation, then they will come into role. So that was the basic ECM, proposed ECM. Second was that 4 primary pumps were used with VFDs. New VFDs were coupled to the new pumps as well as the old pumps. Secondary 14 number, secondary pumps 14 numbers as it is were used without disturbing them, but the old pumps were coupled with new VFDs, and condenser pumps were coupled with VFDs. Low approach cooling towers, 2 numbers, replaced all the 11 existing cooling towers, and an additional automatic tube cleaning system was installed. That served to both the new chillers of 550 TR capacity each, and along with that, a central plant manager or a CPM has been proposed, and they have been installed also.
So, Mr. Ranjit, I hope that clears your question. And now the question from Jambamani Tamilarasan. He is asking about what is the payback period?
Payback period of what? For this project?
Yeah, when he has not mentioned anything, it means it is for the complete project.
Yeah, payback period was, you can say, with that I have not mentioned, but it was even less than 2.5 years. How we have arrived to this figure? That also, let me tell you. The commercial value of the retrofit proposed retrofit project was 5.85 crores, right?
Yeah.
And every year, means the first year, more than 46 lakhs of units were units were saved. Second year, 44 point something lakhs of units were saved, and in the third year, 43 point something lakhs were saved. This many units were saved. If you sum up all these units and multiply with 14, that is the unit rate commercial for commercial application, that will come near about 6 crores.
So that's how it should be. I mean, you have measured the savings for the, I think, 2-3 years. Yeah. It means that the savings are sustained in this particular case. Yeah. And that's what we can say, it is a successful audit and implementation thereafter.
Exactly.
Yeah.
Here I would like to make it clear to one and all that it's not only the energy audit that should plays a vital role, but also the implementation of the ECMs. They also play a vital role or a crucial role.
Yeah.
Because the proposed ECM might be good, but at the ground, if it is not implemented properly,
then there is no use.
Yeah, and if the savings are not computed properly, that also matters.
Correct.
Because I have seen in my career that though the ECMs yield a lot of savings, unfortunately, how to quantify those savings that nobody knows.
Correct. Absolutely. Yeah. So savings delivered is what matters than the energy audit process. Yeah. So we move on to the next question. It is from Mr. Praveen Sargai Raj. So would you let me know how effective was the use of VFDs for the cooling towers?
That's a critical question. Yeah, definitely. If you add VFDs to the cooling towers, they really work wonders. But at the same time, I would like to mention here that you cannot expect that VFDs will deliver the complete savings unless they are not synced with the system properly.
Correct.
Syncing with the system means the automated logic system that comes into role. How much, at what frequency the energy the VFD should work or it should modulate. That is decided by the chiller plant manager, or what we call it as automated logic systems. And that's the way to capture the savings or tap the savings. Because most of the people, those who are ignorant of using a VFD properly or effectively, they think that by reducing down the frequency and changing the or altering the speed of a drive or a motor, they can save a lot. As I mentioned through in the session, that there are interactive effects. Interactive effects are the effects that are that may apply out of the boundary. Like if I control the speed of the fan of a cooling tower, might be possible that I may able to save some tits and bits of energy here through the motor. But finally, my condenser temperature or the condenser outlet temperature, that is going to increase, and because of which my chiller will eat away all the savings, and it will on the top of it, it will add energy consumption to the system.
Hope that answers your question, Mr. Praveen. And now the next question is from Mr. Harish. Many manufacturers do not recommend VFD on condenser water pumps. What your opinion and observation on the same? So mostly this question is pertaining to the OEMs because they discourage any change in the systems. Mr. Yashwantrao, can you answer this question?
Sure, ma'am. If we have to go entirely through OEMs, then what is the role of energy auditor?
Correct.
That is number one. Second is that this coupling of VFD with the condenser pump, that is recommended by an energy auditor. Right. So definitely some based on some certain workings only that proposal was made. Right. Now coming to the third part. As I mentioned earlier, that the VFD modulation should sync with the system. It should be able to control the flow of condenser water in accordance to the ambient temperatures and the condenser inlet and outlet water temperature. So if you don't have any automated logic systems or what we call it sensor kind of installations there, then installing a VFD or coupling a VFD to a condenser pump won't make any sense. That has to be worked out meticulously.
Yeah, exactly. Yeah, I also take this opportunity to we need all the energy auditors, they need cooperation from the OEMs for implementing this kind of systems. There are some changes, but yes, it is for the good. So, and if it is not disturbing any working of the equipments, so there should not be any hesitation from their side also.
No, actually, why they are worried? Why they are worried? They are also right from their point of view. Why they are worried? Let me make it clear to you. Because every system is designed to work under certain standard set of conditions, right? And when we alter the standard set of conditions, then we need to sync that equipment with the current condition. If suppose if it doesn't sync, then it won't work well. That is also a clause.
I hope you are satisfied, Mr. Harish. And now again, the question is from Mr. Rajit. She is asking what is ATCs, that is automatic tube cleaning systems, and how it works.
For that, the person who has
need to have a special session for that.
It will take almost 1 hour for me to
exactly.
Yeah, it's simple. I can just simply since the person has raised this question.
Yeah, so yeah, we should. Yes.
Yeah, I won't disappoint anyone. Automated tube cleaning system is the kind of device that cleans the condenser tubes on and off regularly at certain set under certain intervals of time, and intervals of time are set by the operator as per the need and requirement. They keep on cleaning the condenser tubes and don't allow the condenser tubes to get fouled.
Right.
And it's really a boon, I can say. It's a gift to the HVAC industry, this ATC system, because it saves, it increases the lifespan of the condenser tubes. That is number one. Second is that shutdowns are completely eliminated by using this kind of device. Third is that water wastages are completely eliminated. I have delivered a complete session during the AEEWI conducted by ISHRAE Nagpur chapter last year in the month of September 2023. The complete recording is available with me. If you want, I can share that link with you so that whoever wants to know about automated tube cleaning system, they can watch that YouTube video leisurely, and they can gain the insights of what automated tube cleaning system is and how it works well in HVAC systems.
Sure, we can share that on our AEEWI Western India LinkedIn page also, so
Sure.
that all can watch it. Now,
at least I can
there are calls.
Get more viewership and
Yes.
subscriptions also.
And now the next question is from Mr. Rupak Ingve, our ISHRAE Nagpur chapter president. And let me tell you, I mean, I should have mentioned this before, but today's our session is with association with ISHRAE Nagpur chapter. Thank you, Mr. Ingve, for giving, for allowing us to associate with ISHRAE Nagpur chapter for this webinar. And his question is, were any conventional pulley or fan motors replaced by EC fans in the AHUs?
No, in that particular project, no, that initiative was not taken. The reason
being that, comparatively.
The reason being that our energy audit was conducted only for the plant room only. It was limited to the plant room. We didn't step out of the plant room.
Then again, another question from Mr. Soham Verma. Do VFDs on condenser pumps are linked by certain logic?
Please come again.
Do VFDs on condenser pump linked by certain logic?
Yeah. It all depends on the condenser inlet and outlet water temperature.
Yeah.
That's what I mentioned earlier. The system should sync with the current conditions.
Okay, so that's all for that's all the questions we have. Any further questions? Yeah. So we also take this opportunity to invite memberships for AEEWI Western India chapter and ISHRAE Nagpur chapter as well. So both this AEEWI is only for energy, but whereas ISHRAE, it is working on HVAC and just one, somebody has raised a hand. So yeah, it is from Dr. Hitesh. Yes, Dr. Hitesh, do you have any question? No. Yeah. So we invite memberships for ISHRAE Nagpur chapter and urge all of you to take this opportunity to interact with the technical resources that are available here on the platform of ISHRAE Nagpur chapter and AEEWI Western India chapter. So those who are looking for details can get in touch with us. And for ISHRAE Nagpur chapter, so you can visit to the website of ISHRAE, that is ishrae.in, ISHRAE.in. So it is a largest technical society of India, I can say, which is imparting training for training and providing platform for HVAC fraternity. Yeah. So thank you so much for joining. As there are no questions, we end our session today's session here, and look forward to for all of you for attending the future webinars also. And if you have some suggestions of if you are interested in attending delivering such webinars, just you can contact us and we can arrange for it. And Mr. Hitesh is asking for mic access, so I am granting him. Just a second, Mr. Hitesh, I am providing you my mic access. So you can speak now, Mr. Hitesh. We have provided you access. Dr. Hitesh?
Good afternoon, ma'am. Am I audible?
Yes, you are audible. Very much.
Yes, ma'am. I have a small query. I just recently came to know about this organization. So I am already a member of ISHRAE Nasik chapter.
Okay.
So whether I can become a member of this AEEE Western India chapter?
Yes, this is AEEWI Western India chapter. That is Association of Energy Engineers, and it is headquartered in USA. And in India, this is one of the chapter that we have of the 3. Yeah, definitely. You can drop your email address. I'm writing it in the chat box by email address and phone number, so you can get in touch with us. So let me send my email address in the chat box.
Because you were mentioning this ISHRAE Nashik chapter, so sorry, ISHRAE Nagpur chapter. That's what got me confused about this.
Oh. No, this is you can be chapter for this is for Western India.
Yes, ma'am. Yes, thank you.
Mr. Vaisar, can you just
Should I push off?
Yeah, yeah. Please stop sharing so that I can type the question.
Okay. Is that okay, ma'am?
Yes, it is. Yes, thank you so much.
Okay.
So this is the email address, that is aewesternindia@gmail.com, and my WhatsApp number is 230717702. So if you have any queries or if you have any feedback, you can contact us. So thank you so much for all of you for joining this session, and we look forward to you for the future sessions also as well, and hope more of you become a part of this webinar series. And thank you, Mr. Rao, once again for the wonderful session, and I mean, as usual, your presentation skills are great. And we always love to have a session from you, and look forward to future sessions also.
Thank you, ma'am, for inviting me as a speaker in this forum, and I'm honored to be here as a speaker.
Thank you. Thanks everyone for joining. Bye.
Bye.